Hello everyone, welcome back to MAC1105. In this video, I want to talk about a very important topic in college algebra. Actually, this topic, first time you introduced to this topic is when you were in intermediate algebra. However, in this college algebra, we want to discuss more and we want to explore more about it. It is function, that the topic I'm talking about. So maybe many of you heard this terminology many times, function, and maybe your high school teacher, your intermediate algebra professor talk about this, and they introduce a different type of function to you, like linear function, quadratic function. However, maybe some of you still have not understood what function is. Okay, so today in this video we're gonna go through that concept one more time. Okay, so let's get started. So I'm gonna put the topic today, function. So let's jump to our first part of the video. Definition. What is function to you? What is function? Excuse me. I still have very bad allergy, so bear that with me, okay? What is function? Maybe some of you see the notation f of x, and you guys know that, okay, every time you see f of x, this is function. Yeah, it is. But I'm talking about the definition of function. What is that? What is that? So function is a relation. Okay, a relation between what is a relation between two set of element. Okay, two set of element. Maybe some of you forgot what set is. I mean, this is the term set is actually the first time you introduced to this when you learn intermediate algebra. Also, set is a collection of items. It's a collection of object and thing. Okay, so function is a relation between two sets. It means it's just a relation between two collection of item, or two collection of things, or I can say, make it simple this way, it's a relation between two group of element, okay, in a special way. In a special way. It's not just simple relation, it must be related in a very special way. How special is that? I mean, I'm going to talk about how special it is later, okay? The element of the first set is called input. Element of the second set is called output. Okay, and the first set and the second set also has its own name. The first set we call domain, and the second set we call range. Okay, we call range. So any element on the first set is called input, and element of the second set is called output. Okay, you can think it like this. You can think it like a function is like a machine, and I put meat into the machine, and that machine is gonna help us to make hot dog. Okay, so meat is input. Okay, machine is a function, and hot dog is output. Okay, however, if you put meat into the machine and the machine give you hot dog and burger buns, that is not a function anymore. Okay, so that typical example I give you, it tells you how special the relation is. Okay, so the rule is that for each input, okay, in domain, function it assign a unique output. Here you go. This is the special way they have to follow, okay, in order for relation to be called function. If the relation does not follow this rule, then it's not a function anymore. Okay, it's not a function anymore. So I'm gonna underline over here. I underline this word right here, unique. Okay, this is very important. It's very important. Okay, now I can draw a quick picture so that you can visualize what it looks like. So what if I have a machine like this? Okay, I had a machine, and this machine I consider this machine is a function. Okay, this machine is a function. Okay, and over here is the output. Okay, alright, and over here is the input. Is the outlet, and this is inlet. Okay, so this is input. Input is meat. Okay, and input is meat, and output is hot dog. Okay. Okay, so this input, you put meat into the inlet, and the outlet you have hot dog. So that is a function. That machine is called function. However, if you have also a machine, and the input is meat. Okay, the input is meat. You put meat into the machine. Okay, and the output at the outlet. So the outlet right here. The outlet, there are two things. The hot dog. Okay, and sausage, for example. Then this is not a function. So this machine is not a function. The machine is not a function. Okay, is that clear to you? So it means that for each input you put into the machine, you have only one output. Okay, if you have two different output, then it's not a function. Right? And the notation for function is y equal f of x. Okay, that's the notation of function. And y is called output. X is called input. And because y equal to fx, so the whole thing over here, fx is also output. Fx is also output. Okay, and the output, they also have another name. We call that dependent variable. Okay, and the input, we have another name. We call independent variable. Okay, so I mean the y depends on the x. That's what it means. You know, the hot dog depends on the meat. Okay, you know, if the meat is the pork, then you have pork hot dog. If your meat is beef, then we have beef hot dog, something like that. Okay, I can give you another example. For another example where the relation is a function. For example, like I can say like this. I can say the distance you're traveling, it depends on the amount of gas you have in your car, right? So the amount of gas is independent variable. The how far you travel depends on how much gas you have, right? So the number of miles you travel is dependent variable, okay? Because it depends on the amount of gas you have in your car. So that relation between two quantities there is a function. Or I can give you something like this. What if I have the final grade you receive at the end of the semester depends on the amount of time you spend on learning at home and in class. So the amount of time, that quantity is independent variable, and the final grade could be A, B, C, D, E, F, right? It depends on the amount of time you spend on learning. So that is the final grade is dependent variable. So that relation is also a function. All right. Now I could give you a bunch of different type of function. Okay. You can have different type of function like this. Example number 1. I have f of x equal to, yeah, sorry, recently the weather is changing and my allergies is getting worse, so I don't know when it's gonna, maybe when it's warmer, because right now it's really cold, and you know, my allergy, my throat is kind of itchy. Okay, so bear that with me. Okay, so fx equal to 2x minus 3. So this is a typical example of function, and this is linear function. This linear function. Okay, now I can have something like this. I can have another type of function. How about something like this? This is radical function. Okay, or I can have something like this with absolute bar, and this is called absolute function. Or I can give you something like this. G of x equal to 1 over x. Okay, or h of x equal to 1 over x squared. Both of these is rational function. Okay, there's so many different types of function. I cannot list everything out, but this is a typical example of function we're gonna focus in this class. Especially later on, we're gonna focus on linear function and quadratic function. So this is quadratic function. Okay, quadratic function. Or if I have something raised to the 4, raised to the 3rd degree, then this is called cubic function. Alright, there's more and more different type of function if I want to. But later on in this class, we're going to focus on quadratic function more. We're going to focus on linear function and maybe absolute function and radical function. Okay? And the way we graph those functions is very simple. We just go ahead and set up the table, and we just plug in a point. For linear function or linear equation, we already talked about. We can use in intermediate algebra. We can use rise over run method. That is another way of graphing linear function. But for other functions, most of the time we just go ahead and plug in the value, and the process of plugging the value we call that evaluation. So in the example over here, I'm going to give you a function. Okay, I give you a quadratic function, something like this, and I want you to evaluate fx, okay, at x equal 1. Alright, so I want you to evaluate that. So the evaluation question is very easy, and I I assume everybody know how to do it, so just basically go ahead and plug them back in. So when I say evaluate the function at x equal 1, it means that I want to find the output when given the input of 1. So you calculate output f of 1, right? Because according to the definition, the whole thing is output. So f of 1, you plug it in, 1 squared minus 3, 1 minus 2, which is minus 3 minus 2, which is negative 4. There you go. So that over here. So how we interpret this? So this 1 is input, negative 4 is output. Okay? Good? Excellent. So that's how you evaluate a function. Now on the second part of our lecture, I want to talk, because after we know what function is and what function look like already, so how we represent a function, and how many methods to represent a relation to be a function. So in the second part of the lecture, I want to talk about function representation. Function representation. And there are three different ways. There are three different ways of representing function. The first method, which is we use table. Actually, I already mentioned a table in last time. When you're graphing. So I have I have a table like this. Okay, and I hope that after I get the table, then somebody can help me find if the table is represent function or not. Alright, so I have over here date of October. At the bottom here I have temperature. Okay, so I have 19. Is there on the 19, on the 20, 21, 22nd, 23, and 24. Okay, and over here I have 52 degrees on the 19th, 65 degrees, 69 degrees, 72 degrees, 67 degrees, and 58 degrees. Alright, so I have a table like this, and this is a relation, but I don't know that this relation is a function or not. We need to check. So how we check that? We're going to use the definition. We're going to use the definition of function. The definition of function is what? The rule. For each input in the domain is to assign a unique output. Okay. Let's check. Let's check if it assigns unique output or not. So this is input. Alright, so at 19 assign 52. This is assigned to this. 21 to 69. 22 to 72. Yeah, right. 23 to 67. 24 to 58. Yeah, it's a unique output because no one output assign two different no one input assign two different outputs. So this one is good, right? This one is good because everything is unique. So this is a function. This is a function. Okay, this is a function. Alright. How about this one? I have another table. And this is input is the person weight in pound, and over here is person height in inches. Okay, and I have 125. Okay, I have 64. 125. I have 200. This 64. This assign 64. 72. All the data over here I collected. I made them up. Okay, it does not reflect the reality. You know, 107. 60. Oh, I'm sorry. This is 59. Okay. And over here, let me see. I can make a little bit brighter. No, look like that's the only way I can do. 200, 68, and 132, 66. Okay, so let's see. So if you guys notice, you see that. If you guys notice, you will see that right over here is 200 is the input, right? It assigns 72 and it assigns 68. So you saw one input give you two different output. One input give you two different output. So this relation, it can be a function. So this is not a function. This is not a function. Okay, this is not a function. Alright. Alright. Excuse me. Alright. A second method of representing function, which is we can use set. So set is collection of items. So in this example, in the example for this, I will give you a set of points. Okay, so I have a set A like this, and because the reason I use point because point have x and y, right? X component, y component. So x component over there could be input, and y component could be output. So I have a few points like this: 3, 1, 2, 5, 4, 2, 1, 0, 3, 4. Okay. Alright, so I have 5 points like this. Now let's check. So all of this is input, 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 out, 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 out. Okay, and let's see if this one it assign unique output, a unique output or not, or one input assign two different output. Oh, look at this. When you have 3, it assign 1. You have 3, it also assign -4. So one input gives you two different output. That is not good. This is not a function. It's not a function. Alright. How about set B like this? Set B like this. 1, 4, 2, 3, 3, 4, and -4, 5. Alright, do you think this is function? Alright, let's check. -1 assign 4, 2 assign 3, 3 assign 4, -4 assign 5. Yeah, it is function. Okay, maybe some of you kind of asking like, how about over here we repeated number 4? That's okay. You know, -1 assign 4 and 3 assign 4. That's still okay. Okay, so if the y repeated, it's still okay. But if the x repeated, that's not good. So this is still a function. Okay. And the final method of representing function is we can use a diagram. Okay, so it's diagram. Okay, so 3 diagram. So I have a diagram like this. I have a diagram. Okay, in the diagram is like two little eggs like this. Okay, over here is the input, and over here is the output. And in the domain set, in the input set, I have some element. Okay, so over here I put 5, 7, and 8, and 9, and over here I have -1, 4, 28. Alright, and I have it assigned like this. 5 assigned to 1, okay, 7 to 4, okay, 8 also to 4, okay, 9 to 8, okay, and 5 going to 20. Alright, so if you notice, you see that 5 going to -1 and 5 going to 20. One input gives you 2 output, so that contradicts to the definition of function. So this is not a function. Alright, maybe somebody you ask me, how about 7 and 8 going to 4? That's okay. If 7 and 8 going to 4, that's fine. Okay, but because 5 going to -1 and 5 going to 20, so that is not a function. So as long as you know a relational function, then all the input value will be a part of the domain. Okay, the output will be the range. If it is not a function, then who cares about domain range? You know, it is typically all input, but it's not the part of the domain. So on the third part of our lecture, I want to talk about domain and range. What is domain and range? You know, maybe some of you think like domain is on the x value, yeah, but it's not good enough. It's not clear enough when I say domain is just the x value. Okay, domain is all the x value that make the function divide. That's the true definition of domain. Okay, domain is all x value which make the function define. Okay, make the function define. How we understand this term right here, define? What does it mean by define? Define means that I'm going to use red color over here. Define literally it means that you can evaluate it. Okay, you can evaluate. That's what it means. That's what it means. Define. You have to be able to evaluate that. It means that you can plug them in and calculate it. Okay, or you can plug in and calculate it. All right. If you cannot plug in, if you can plug in and but you cannot calculate it, okay, then then that value does not belong to domain. Okay, remember that value does not belong to domain if you cannot calculate it, if you cannot evaluate it. All right. For example, I give you something like that. Example 1. Follow me. I give you the function like this. Okay, f of x equal to 1 over x. So I have the function like this, and anyone can tell me what value when you plug it in here, and you cannot calculate it. What do you think? I think a little bit. What value you plug it in, and you cannot evaluate it, you cannot calculate it. How about 2? Alright, 1 divided by 2 work. How about -1? 1 divided by -1 still work. How about 0? Oh, 1 divided by 0, it's not working, right? You go ahead and put it into calculator. You put 1 divided by 0, it's not working. So it means that the denominator it cannot be 0. Okay. So at value 0, you cannot evaluate it. It means the other value you can. Alright, so it means the domain will be what? Domain will be negative infinity to 0, because you don't want to include 0, union with 0 to positive. Right? That makes sense, right? Just think about it. You have on the number line, you have the whole number line, right? And because 0 is not working, 0, it doesn't work, so you remove the 0 out. You remove the 0, then on the number line, this is what you have left. Okay? This is what you have left. How about this one? How about I have something like this? Alright. So what value it doesn't work? 2, right? Because 2 minus 2 is 0, 1 divided by 0 doesn't work. I mean, to some of you, if it's so hard for you to find that value, then you can do it like this. You can set it up. Okay, set it up is the way to show work. So you set up the denominator can be 0. So x different from 2. So the domain will be negative infinity to 2, not included, right? Just the whole number line. You remove number 2 out. 2 plus infinity. There you go. Alright. How about this one? Example 3. Function like this. 3 over x minus 5 x plus 3. Alright. If somebody you can see right away, but if it's hard for you to see, you can just go ahead and set it up different from 0, and you solve for that. So over here you can apply the 0 product property. Alright. So here you have x different from 5, x different from negative 3. Alright, so on the number line, you just remove 5 and negative 3. Remove 5 and negative 3. I mean, I'm gonna go ahead and draw the number line so that you can, it's gonna help you to see better. So I have a number line like this. It's negative here, so it's negative 3 here and 5 here. Positive infinity. And over here, I remove it. It means I put an open circle. It means we don't want it. Okay. So the rest of them will be the domain. So, alright, this will be the domain, this will be the domain, and this will be the domain. Alright, I just remove this. Alright, so basically we have three parts, not just one part. So the domain will be negative infinity to negative 3. Right, parentheses, because we removed that already. Union. Don't miss in the between, okay? Negative 3 to 5, union 5 to positive infinity. There you go, something like that. Okay. Or now let's change a little bit. Let's try to find domain of another type of function. So how about I have the function like this. G of x equal to square root of x. Here you go. Then how do I know that what value you cannot evaluate? Well, if you take square root of 0, so 0 still works. However, the negative number doesn't work, right? So it means what? All inside of here must be greater than or equal to 0. Set x greater than or equal to 0. Alright. So the domain will be bracket 0 to positive. Here you go. Simple like that. So this means literally this means that all the value as long as it's greater than or equal to 0, then you can evaluate. If it's less than 0, then you cannot evaluate. Well, it makes sense because it's square root. Alright. Or how about if I can, this is example 4. How about I have something like this. How about I have this? 2x minus 3. Alright. I see. If it is hard for you to see, then just go ahead and set radical greater than equal 0. Okay, and you can solve for x. Everybody know how to solve linear inequality. X greater than 3 over 2. Then the domain will be greater than. Okay, greater than, it means on the number line. So if you go ahead and draw the number line, you know, it's the 3 over 2 right here, and we want to include it. Okay, it's positive infinitive, and this is what we shaded, right? There you go. Alright, so that's why must be bracket, right? Must be bracket. You know what? I'm gonna put here. You got make a dot right here with yellow also. So it'll be 3 over 2, 2 positive. There you go. See that? That's simple. Alright, how about I put the radical under denominator? What happened? How about if I have like this? 4x minus 2. Alright, so in order to do this, again, you're going to set up the radical greater than 0 only. But so instead of set greater than equal 0, you just need to set greater than 0. So you see the difference? See, this is no equal because the radical under denominator. Okay, if you see the radical under denominator, you just put it greater than 0, no equal. Okay, then you solve for that. Then the x greater than half. Alright, then from here, if you not good, go ahead and draw the number line. Okay, go ahead and draw the number line. So I have the number line like this. So I have 1 over 2. Alright, so there you go. And then you just go ahead and set it. There you go. Alright, like that. Okay, so that's why your domain will be parenthesis 1 over 2 to positive infinity. Okay, the reason you set it to the right because it's arrow. You see the arrow? The arrow is pointing toward the right hand side, so you have to set it on the right. Okay. How about this one? Now let me combine. Radical and something at the denominator at the center. How about I have like this? X minus 2 on the top and the bottom is x minus 5. Alright, and I want to find domain here. Okay, same thing, you're going to do the same thing because the radical on the top, so you just set, okay, with so you set this greater than equal to 0 because it's on the top, so it's equal. Okay, and you set this different from 0. Alright, so this is x greater than 2, x different from 5. Okay. Alright, now the problem is kind of hard for you to visualize the number line and get the interval notation. So again, I recommend go ahead and put it on the number line. Get it here. Positive infinity here, negative infinity here. So I have 2 over here and 2 included, huh? I have 5 right here. 5 different from 5, so 5 not included. Okay. So what you set it because greater than 2, huh? So you set it. You set it here. So we here. You will share. Let me use different color here. Let me use this one. So greater than 2, it means you're going to set everything, right? You set everything. But you don't want to set 5 off because we don't want to include 5. Okay, here you go. Because it's different from, you see. It's not 5. 5 doesn't work. 5 you plug it in, not work. So based on that, I can get the domain. So the domain will be 2 bracket 2 5, right? Because you don't want to include that. Union with 5 to positive infinity. Okay. So that is how you find domain. I mean, finding domain is kind of a tough one, tough question. I mean, especially if the question is hard. So you see that I always start from the easy question to the harder one, and I can go a little bit harder. Okay, let's go a little bit harder. Let's start with example number 8 here. Domain. Okay, following function. How about on the top? Excuse me. On the top, I have a radical. Okay, and over here I have x plus 1. At the bottom, I have a denominator x minus 2. Okay, and another radical, maybe x plus 2. There you go. Let's see how we do that. This is more complicated, huh? Alright, so answer. That's okay. Don't feel so bad, you know. You just do the same way as I do. You set up and you set this greater than 0. Okay. And you set this because it's under denominator, so you set x plus 2 greater than 0 only. And you set this different from 0. Alright, so you solve for that. Solve for that. Alright. And you solve for that. And now you're going to put on the number line because it's very hard for you to visualize in your brain. So you put on the number line so that it's easier for you to get the interval notation. So you put -1 here, have -2 here, and you put 2 here. Alright, so first of all, let's do this one, -1, right? So it means that over here we want to include it because it's an open circle. So it's an open circle. Hey, it's a closed circle. I'm sorry. It's a dot because we want to include it. So it's a dot. So, but however, over here we don't want to include it. So this is an open circle. And over here this is also a open circle. Right. So we included greater than, to me we set everything except for that open circle. Okay. And over here, I think I'm going to use different colors so that you guys can see it. I think I'm going to use this color, maybe this one right here. Let me use the red one, the purple one. Here you go, because we don't want to include this. So open circle. And we set everything because it's greater than -2, right? So we set everything. Okay, we set everything here. We set it. Overlap the orange. There you go. So that's what could be the final answer. What will be the final? So it means that we want to have greater than -2. So whatever overlapping we're gonna take. We're gonna take the overlapping part only. So it means that we're gonna go from -1 included, right? Okay. To 2, huh? To 2 not included. Alright. To 2 not included. Because not included over here already. We don't want to have 2, okay? Union with 2. Okay, union with 2. 2 what? Union with 2 positive. There you go. Okay. Let me see if it's correct or not. Greater than -2. Okay. Yep. right? That's what we want, right? Because it's overlapping, right? That's what we want. Okay. -2. I just want to make sure that I got it right. So we want from -1 greater than -1. So if it's less than -1, if it's less than -1, for example, -1.5, then you see that doesn't work on the top, huh? Yeah. Yep. So that's what it is. Alright. So this is the final domain. So make sure that you find intersection, you find the overlapping part. You know, by overlapping part. This is kind of challenging problem. Okay. Most of the time, maybe I'm just, we don't do the radical on the top, just the bottom here and the radical on the bottom, or maybe the radical on the top and the fraction the bottom like this, you know. So you have to be flexible. Try to use the logic. Okay. All right. And so far, you know that if you do the definition of function, you can tell if the relation is a function or not. However, if they give you the graph, so if they give you the graph, then how do I know that a graph represents function? We're going to use a test called vertical line test. Okay, vertical line test. The vertical line test tell you that. Let me erase this a little bit here. Vertical line test tell you that if a vertical line cut the graph at one point only, then that graph is a function, represent function. Okay, for example, like this. I have the graph like this. Okay, I have the graph like this. Okay, y here, x here. Let's make it a graph, okay? Over here I have an open circle, and I'll go all the way up here, and down here, and up here. Okay, dot. Alright, you go ahead and you put the vertical line here, and you see that it cut at only one point, right? Cut at only one point, then over here satisfy a vertical line test. Okay, so you see that if we apply the vertical line test, the line is only cutting the curve here at one point, no matter what, how you put it. Okay, so it cut here 1 point, 1 point, 1. So all of them is 1 point. So it means that the graph over here represent function. The graph over here represent function. How about this one? How about this one over here? What if I have a circle? Okay, what if I have a circle? I have something like this. Okay, and have a circle, huh? Have a circle. So you see that if we go ahead and draw the vertical line, if I draw the vertical line, you see that it cut at more than 1 point. It cut at 2 points here. See that? So this is not a function. So this is a function, and this is not a function. Alright. Vertical line test is very easy. Very easy to use. Alright, in example number 3, okay, I'm gonna give you the graph, and let's see you can get the domain and range of this graph or not. Okay, so I have let me use the this color here. So maybe we should use this color. So how about this? Okay, I have an open circle right here, and I go from here up to here. Okay, go all the way down and going up to the dot circle here, that one. So if you go ahead and read this, you you know, the domain, you always go from left to right, and you have to look at the x for the range. Okay, so the domain you start from left to right. Okay, you always go from left to right, so they start with -5, right? But it's open circle, so you have -5 to what? To 8. 8, right? That's usually your domain. How about the range? The range you start from from the bottom up. So you start from here. It's about 1. It's not even. It's 1.1, huh? It's 1.1. It's 1.1 included, right? Because it's right over here is the lowest one, and this is if it's no dot nor the circle, it means it's included. So it's 1.1 to 1.12 to what? 29 bracket. 29 bracket. There you go. So that's how you can find domain and range given a graph of the function. All right. How about this one? Let me put the coordinate system in. Let me put the coordinate system. Let's see. Right. So I'm going to put the coordinate system here. You know what? I'm going to make it a little bit longer. Oops. I cannot do that because if I change it, everything will be changed. Yeah, so I don't want to change it. Alright. So I'll put the coordinate system here. Let's see, I'll make it a little bit bigger here. Okay. Alright. This is example number 3. Okay. Alright, so let's go ahead. Put a graph here. So right now I want the graph go like this, and this is the dot 1, and I want to go up to this one. There you go. And from here I have another dot, and I go up to this. Okay. And from here I have a dot side, and maybe I make a curve like this and go to like that. Alright, so first of all we need to know if this function or not. Well, if we go ahead and apply the vertical line test, and you see that, yeah, it cut at one point, even though they have a disconnection, but doesn't matter. If you see the graph and you draw the vertical line, it cut only one point. Yeah, so this is function. Okay, how about domain and range? The domain for this one will be what? So you start from left to right with respect to the x. Okay, so you go from -7, right? -7 included because it's a dot, and you stop at -4. It's parentheses. Then you union with -2 bracket. Then you go to 2 parentheses. Then you union with 4 right here, right? 4 right here bracket. Okay, then all the way to 10 parentheses, right? Because it's open circle. That's for the domain. How about the range? The range will be what? You're looking from the bottom up, so you start from -3 is included. -3. And you go all the way up to 2, even though over here is 2 is not included, but over here is still included, so it's still good. It's included here. All the way to 9, so 9 is not included. There you go. There you go. That's how you get the domain and range. Let's do another one. It's more complicated. Okay, let me put the coordinate system in. Okay. See. Alright. Now guys, I have something like this. Now let's draw a graph. So I have over here, I have let's make another color. How about this one? I have over here. Okay, then I have it all the way down here. Okay, and up here. That's the dot side. Then from here, I have the open circle. I make it all the way down here. And I make it up, alright, like that. Alright, and from here I have dot and go all the way down to like this with the arrow. There you go. So let's see if it is a function or not. Alright, let's check, apply the vertical line test. Yes, it is. It is function. Okay, it is. Let me make a little bit this better. There you go. There you go. You know what? I think I'm gonna erase a little bit over here. Let's change it. Here you go. Oops. Okay, let's redo it. So open circle here, and you have all the way over here, right? Okay. There you go. Let's do that. Alright, if you go ahead and apply the vertical test and you see that it cut only one point no matter what you go from left to right. So the domain will be what? Domain will be, you start from -7 parentheses and go all the way to -2, even though it's not included here, but it's still included here. So it still work. So all the way to 5, right? Included bracket in union with 7 bracket, 7 to what? To infinity. And how about the range? The range, you always start from bottom up, meaning you start from -infinity. Alright, then go all the way to, let's see, go all the way to, just include it, go all the way to 7. You say all the way to 7 is the highest value, right? It's no more than 7. And even though we don't have it here, but 7 is still included. There you go. The range. Okay. So that's how you find domain and range. I mean, you look at it from left to right, and you see, you look from bottom up for the left to right for the domain and bottom up for the range. Okay. And all the function I give you here is a function. So on the graph here is a function. You know, if it is not a function, there's no need of finding domain, no range. Okay. Good. All right. Okay, so in part 6 of the lecture today, so last time is part 4, or this part 4, in part 5, sorry. So part 5, I want to talk about some basic parent function we're supposed to learn in college algebra. Basic function, and we're gonna discuss the domain and range of this basic function. Okay, this basic function over here sometimes we call the parents function, because from this function we can derive more different type of order function, which is more complicated than the basic one. Okay, so the first one is the linear function. You know, linear function is in the form f of x equal to x squared. F of x equal to x. Sorry, that's not x squared. Equal to x. Okay. All right. It's linear function, and this is the basic one. Okay, and the graph of this basic linear function is going to be something like this. This is a straight line, okay, and this straight line going through the origin and make 45 degree with the going through the origin and make 45 degree with the x-axis. Okay, straight line. And if you look at the line over here, I know right away the domain will be from -infinity to +infinity, and the range will also from -infinity to +infinity, go from bottom up and left to right. Okay, that's the first type of function, the basic one. The second one is the square function. Square function, or as this quadratic function, it's the same thing. Okay. Okay, and it has the form like this: f of x equal to x squared. Excuse me. Okay. And the graph of this function is a parabola. Okay, and it's going to be opened up like this, and it's going to be at the origin. Okay, and you know right away that the domain will be from negative infinity to positive infinity, and the range, of course, will go from 0 up, so it will be a bracket 0 to positive infinity. Okay, so order function I'm talking about now is the basic one. Okay, the parent function. Okay, number 3 is a square root function. Square root function. Okay. The square root function, they look like this: f of x equal to square root of x, and the graph of this function will be something like this. You guys have to memorize all of this function because it's very helpful when you learn a transformation concept, which is in the next couple video, or maybe in the next couple class. We're going to talk about a transformation of functions. So the graph of this will be, the sketch of this function will be something like this, and you know the range, the domain will be go from 0 to positive infinity, and the range will be also from 0 to positive infinity. See, the range go from 0 up, and the domain go from 0 to the right. Okay, square root function, or sometimes we call it radical function. Number 4 is cube root function. Cube root function, or the third radical function, the same thing. So I have a function like this: I have f of x equal to cube root of x, and the sketch of the cube root function will be something like this. Something like this, and go up like that, and go like this. And you go through the origin, okay? You go through the origin. So from here, I say that the domain will be from negative infinity to positive infinity, and the range will go from negative infinity to positive infinity. Okay, it's very easy. Number 5. What else? How many functions already? 1, 2, 3, 4, 5. Alright, the next one will be absolute function. Okay, absolute function. The absolute function has the shape of letter V. So I have f of x equal absolute of x, and it look like this. Okay, it look like this. Letter V at the vertex is right at the origin. Okay, there you go, something like that. Okay, and this is x and this is y, and we know right away the domain will be go from negative infinity to positive infinity, and the range you start from 0, so we got absolute of 0 is still 0 to positive infinity. It's very easy. Okay. How about the cubic function? Alright, let's say cubic function. Cubic function look like this: f of x equal to x to the third power, and the graph of cubic function will be something like this. You gotta memorize all of this. You see that? I memorize all of this. There you go. It's gonna be something like this. So the domain will be from negative infinity to positive infinity. So is the range. Alright. Of course, you have to memorize on domain range too. Number 7. Rational function. Okay. So the rational function, I'm going to categorize it into 2 different types. The first type is f of x equal to 1 over x, and the second type is f of x equal to 1 over x squared. Alright, and the graph of this one will be something like this. Something like this. Alright, and something like this. Okay, so the domain here will be negative infinity to 0, union 0, positive infinity. So is the range. Negative infinity to 0, union 0, 2 positive. But for this one, the graph, the sketch will be something like this. Going up like that. It's not gonna cut, okay? And it's gonna go down like this. Okay. Okay, and the domain will be what? Domain will be know from negative infinity to 0 union with 0 to positive infinity. Okay. Oops. Try to erase it. It's not working. Okay. Okay. Union. Oops. Union 0. There you go. How about the range? The range a little bit different. The range go. We don't have. You see that we don't have anything down here. So the range go from 0 to positive infinity because it's not included 0. See that? You see the curve over here is get close to the x-axis, but it never cut the x-axis. So this the 0 cannot be included in the range. Okay. Okay, so let me see if we miss any other function. Look like we're okay with that. So this is 7 basic functions you guys must know. Okay, you must memorize the sketch. Okay, and the domain and the range of all of these functions. Okay. All right. So I think I'm gonna stop the first video over here. Okay, let me know if you have any question. Then in the next video, I will be keep talking about function, more things to know about function. All right, I'll see you next time.